Hello students, welcome to my YouTube channel DR Mathematics and also welcome to the chapter of relation and function. In this particular session, we are going to discuss about the topic of function. So let us start the topic function from the definition of the function. Let A and B be two non-empty sets. A relation f from A to B, that is a subset of the Cartesian product of A and B across B, is called a function or a mapping from the set A to the set B if for each A belongs to A. That means if for each and every element belongs to the first set, there exists V belongs to B. That means there exists an image in the set of V such that the order pair AB belongs to the function. Again, if AB belongs to the function and also SC belongs to the function, you must be clear that both of the elements V and C which are present in the second set are equal with each other. Okay, let us discuss about the definition of the function by using the arrow diagram method. Suppose this is the first set A and this is the second set B. Suppose there exist three elements. This is x1, x2 and x3, and there exist y1, y2, y3 and y4. For each and every element present in the first set, there must be an element B. I have taken here y1, y2. Suppose x1 is making order pair with y1, x2 is making order pair with y2, x3 is making an order pair with the element y3 in the set of V. Then this is called as a function. But basically there exists another condition here. If there exists another element y4 and it is also making an order pair with the element x3, then you must be clear that this y3 and y4 are equal with each other. In this case, just by transforming or by simplifying this diagram, we can remake another arrow diagram here, x1, x2, x3, and here y1, y2 and y3 or y4, because these two elements are equal according to the given conditions, according to the second condition of the definition of function. You have to write down either y3 or y4, because if x3 is making two order pairs with two elements present in the second set, then you must be clear that both of the elements present in the second set are equal with each other. So here x1 is making an order pair with y1, x2 is making an order pair with y2, and x3 is making an order pair with y3 or y4. So you can write down one of the two elements y3 or y4, because y3 is very much equal to y4 here. So this is called as a function. This is a function. So the necessary condition or the requirements are each and every element those are present in the first set must have an image in the second set. If x1 is making an order pair with y1, then y1 is the image of x1. If x2 is making an order pair with y2, then y2 is the image of x2. If x3 is making an order pair with y3, that is present in the second set, then y3 is the image of x3 under the function f. And these are the conditions. That means if there are three elements present in the first set, then you must see that in the function there will be three order pairs, and the three order pairs will be different. One is x1, y1, another is x2, y2, and another is x3, y3, and three mappings are there from the three elements of the first set. So it is all about the definition of the function. Then moving towards to the sum of the nodes. If AB is an order pair which belongs to the function, then V is called the image of A under F. I have already told you. Let us again revise it. Suppose A is an element present in the set A, B is an element present in the set V, and A is making an order pair with the element B which is present in the B set under the function f. Then B is the B is the image of A under F. If we are proceeding towards from left to right, then we can call it as V is the image of A. Suppose we are proceeding from the right side to the left side. Suppose we are proceeding from, okay, this is the image what? If this is image and we are reversing the direction, then A is called the free image. A is called the free image of A under the function f. So again, as B is the image of A under F, so B is called as f of A, and this is very important. Okay, so what are some of the examples that can be possible based upon the function topic? Let us discuss about them. So here it is the example number 1. I have taken here two sets, two non-empty sets. A is set containing 2 elements 1, 2, and B set containing 3 elements 3, 4, 5. And I have to take some of the examples of some of relations, and then we have to examine whether these relations are functions or not. If they are not functions, then we have to justify it by giving some reasons. So the first one is, suppose I have taken here R1 is equal to 1, 3, 1, 4, 2, 5. The second one is 1, 3. The third one is, I have taken here 1, 3, 1, 5. Then the fourth one is, R4 is given by 1, 3 and 2, 5. These are some of the examples of some of the relations. These are 4 relations I have taken here, and we have to examine that, or we have to check that whether these relations are functions or not. If they are function, then it is okay. If they are not function, then we have to justify it. So here it is the solution. Given that A set is equal to 1, 2, and V set is the set of the elements 3, 4 and 5. R1 is a relation. This is the first bit. R1 is a relation from A to B, defined by R1 is equal to 1, 3, then it is 1, 4, then it is 2, 5. And we have to check it whether it is a relation or not. 1, 2, 3, 4, 5. Here it is given that 1, 3 is an order pair, then 1, 4 is also an order pair, then 2, 5 is an order pair. 1 is making 2 order pairs with 3 and the second one with 4, and 3 is not equal to 4. So that means 1 has 2 images in the set of V. So it is not a function. It is a relation, but it is not a function because the element 1 belongs to A has 2 images in the set of V. So it is not a function. It is not a function because the element 1 belongs to A has 2 images in the set B. This is the reason. Then moving towards to the second relation. We have already discussed about it. If suppose there is an element x1 in the first set, if it is making 2 order pairs with y1 and y2, then, and suppose another element is there, x2 is making an order pair with y3, then it will be a function if and only if it will be a function. It will be a function if and only if y1 is equal to y2. these two images must be equal with each other. But in the previous example, you can see that it is one is making two order pairs with 3 and also with 4. But here 3 is not equal to 4. That means these two elements are different from each other. So it contradicts to the fact y1 is equal to y2, because we require there y1 is equal to y2. Then in that case we can call it as a function if the two images y1 and y2 are equal with each other. But here 3 and 4 are not equal to each other. That means both of the order pairs 1 3 and 1 4 are different from each other. Then moving first to the second relation. So it is the second bit. R2 is a relation from A to B defined by R2 is equal to 1 3. It is 1 2, then it is 3 4 5. This is the first set and this is the second set. 1 is making an order pair with the element 3, and that means 2 has no images in the set of V. If 2 has no image in the set of V, that means it contradicts to the definition of a function, because the definition of a function tells us that each and every element present in the first set must have an image in the second set, but 2 has no image in the second set. So it is not a function. It is not a function because 2 belongs to A has no image in the set V. Then moving first to the third bit. R3 is a relation from A to B defined by R3 is equal to 1 3 1 5. 1 2 3 4 5 1 3 1 5. Here also it is not a function, because it has two options we have here, because 1 has more than one image in the second set, and also in the second bit 2 has no image in the second set. So R3 is not a function. R3 is not a function because the first one is the element 1 belongs to A has more than one image in the set V. In the second bit, the element 2 belongs to A has no image in the set B. So there are two conditions or two options we can write down why it is not a function. Then moving to the fourth bit. R4 is a relation from A to B defined by R4 is equal to 1 3 2 5. One is making an order pair with the element 3 in the second set, and then 2 is making an order pair with the element 5. And here you can see that each and every element of the first set is making an order pair or have an image in the second set. There is remaining a element, or there is remaining a point 4 here in the second set, which has not been attached to any element in the first set, but we have no condition through the elements of the second set. We have only conditions for the first set. each and every element of the first set have an image, and that image must be a unique image. So the condition is here for the first set, not for the second set. So there is a remaining an element 4 in the second set, but we have no condition about that. So you can write down R4 is a function, and we don't have to justify anything here because this is a function. Then moving towards some of the another examples based upon the topic function. So here it is the second example based upon the definition of function, and here also as like as the first example we have to examine whether the given relations are function or not. If this is a function, then it is okay, and also if this is not a function, then as like as the first example we have to justify our answer why it is not a function. So here the same sets are given to you. The first set A containing the elements 1, 2, and the second set B containing the elements 3, 4, 5, and some of the relations are given based upon the two sets A and V. So first of all, let us go through the given conditions or given sets. Given that A is equal to 1, 2, and V set is given by 3, 4, 5. R1 is a relation from A to B given by R1 is equal to order pair of x, y such that x less than y and x belongs to A and y belongs to B. So this is the set A and this is the set B, 1, 2, 3, 4, 5. We have to go through the given condition, and the relation in between the first element and second element present in the order pair in such a way that the first element is less than the second element. 1 is less than 3, 1 is less than 4, 1 is less than 5, similarly 2 is less than 3, 2 is less than 4, 2 is also less than 5. That means all the order pairs, the total Cartesian product is present here. So R1 is equal to 1, 3, 1, 4, 1, 5, 2, 3, then 2, 4, and 2, 5. So all the order pairs are present here, and you can see that we have to satisfy the two conditions in the first set only. And here the conditions are not satisfying here. The element 1 and 2 have images, but more than one image. So it is not a function. It is not a function because the elements 2, 3 belongs to A have more than one image in the set V. Have more than one image in the set B. Okay, the elements 1 and 2, not 2 and 3, the elements 1 and 2. 1 and 2 have more than one image in the set B. Then moving towards to the second relation. This is the first bit. This was the first one. Then moving through the second relation is given by collection of all order pairs such that given by condition y is equal to x plus 3. That means the second element is the 3 added by the first term. Okay. So here the second one, R2 is a relation from A to B defined by R2 is equal to collection of all order pairs such that the second element is 3 more than the first element, where the x belongs to A, that means first element belongs to the first set and the second element belongs to the second set. This is the A set, this is the B set, 1, 2, 3, 4 and 5. 3 more than 1. 3 more than 1. X is here 1. 1 plus 3, it is 4. 3 plus, then 2 plus 3, it is 5. And you can say that it is a function because 1 has an image and a single image. 2 also have an image and a single image. All the elements of the first set have image and a unique image, a single image in the second set. So here R2 is equal to 1, 4 and 2, 5. It is a function. It is a function. Then similarly, moving through the third bit here. R3 is a relation from A to B defined by R3 is equal to collection of all order pairs such that x greater than y, where x belongs to A and y belongs to B. 1, 2, 3, 4, 5. We have to find out such order pairs in which the first element is greater than the second element, and it is impossible here because 1 is not less than 3, 1 is not less than 4, 1 is not less than 5. Similarly, 2 is neither less than 3, nor less than 4, nor less than 5. So no order pairs can be formed here. That means the relation is here very much equal to 5. No relations can be formed by using the given condition. That means if there is no order pair, that means there is no image of the elements 1 and 2 of the set A. If there is no image for the elements present in the set A, then it is not a function. It is not a function. It is not a function because the elements 1 and 2 belongs to A have no image in the set B, and this is the justification or the reason why it is not a function. Then moving through the last bit. R4 is a relation from the set A to the set V defined by R4 is equal to order pair of xy such that y is equal to x plus 4 for x belongs to A and y belongs to B. 1, 2, 3, 4, 5. We have to collect such order pairs in which this condition must be satisfied. That means the second term is 4 more than the first term. Then 4 more than 1, it is 5 because 1 plus 4 is 5. Then 4 more than 2, then 2 plus 4, it is 6, but 6 is not present in the second set. So 2 cannot form an order pair by using the elements of the set B. So only the single order pair is there. R4, it is 1, 5. That means there is a only element remaining here, that is 2 in the first set. That means it contradicts to our the given definition. That means 2 have no image in the set B. This is why this is not a function. So this is not a function because the element 2 belongs to A have no image in the set V. Then moving to some of the rest examples, then we can conclude our today's session. So here is the last example based upon this video. If f is a function from the set A to the set V defined by f is equal to order of pair of 1 1, then order of pair of 2 2, and at last order of pair of 3 9, then find f of 1, f of 2, and f of 3. So given that f is a function from A to B defined by f is equal to order of pair of 1 1, order of pair of 2 4, then order of pair of 3 9. Then go for the arrow diagram representation. It is 1 1 2 3 2 4, then 3 9. So the image of 1 is 1 under the function f. 2 has the image 4 under the function f. So 3 has the image 9 under the function f. So this is called as f of 1. This is called as f of 2. And this is called as f of 3. So here f of 1, the image of 1, is it 1? Then the image of 2 under the function f, it is 4. Then the image of 3 under the function f, it is 9, and this is the solution. So in this video session we have just started the topic of function by introducing the definition and then some of the examples which are based upon the definition of what. In the next video session we are going to discuss about the domain, codomain and range of the function and some of the examples based upon those domain, codomain and range of the function. Till then, thank you.